Hello everyone, this is Martha once again from the Academic Support Center at Raritan Valley Community College. This video is going to be about section 3.1 from the Blitzer book for pre-calculus, and it's on the transformation of exponential functions. Exponential fun! So over on the side we've got kind of a chart that we're going to talk through, and then we're going to go through and do some examples of transformations. So if we look at the top box, g of x just means our function. We've got our base to the exponents, and then if we have a plus or a minus c just means some number, before or after, that's going to result in a vertical shift because our y's are changing. So we're moving up or down the y-axis. And if it's plus c, we're going to be going up. If it's minus c, we're going to be going down. So if we have something like 2x plus 4, 2 to the x plus 4, that is an exponential function, and that plus 4 out here means that it's going to move up 4 spaces. Now let's see what happens if we have that plus or minus c in the exponent. For the second box, we're talking about horizontal transformations. G of x, or just our function, equals b, and then up with the exponent we have x plus c, or bx minus c. Now if it's b to the x plus c in the exponent, we're going to go to the left, to the left, to the left. And if it's b and then x minus c, we're going to go to the right. So if we have 4 to the x minus 2, that x minus 2 being up in the exponent, it will result in a horizontal shift 2 to the right. Now what about reflections? If we've got a negative outside of our base to the exponent, it's going to flip or revolve around the x-axis. Now if we've got that negative attached to the exponent, it's going to flip around the y-axis. And these little curly cues are just my way of drawing flip or reflection. Now, what if we have a number, we're multiplying something? We've got a c out here, some other constant times our base function. That's going to result in a vertical stretch or shrink. If that c is larger than 1, it's going to stretch it. If that c is between 0 and 1, or a decimal or a fraction, then it's going to shrink it. So I tried to draw a smaller arrow. Now, if we have our exponent, if we've got something extra attached to that exponent, like our equation equals 6, or our base 6, 2x, that would be an example there. If that number is greater than 1, it's going to shrink it. So with this 2x, there's going to be a horizontal shrink. So we drew a smaller arrow. Now if we expand it, a horizontal stretch will result if that c attached to the exponent is between 0 and 1. So if it's a fraction or a decimal. So let's take a look at an example, and this one is from the book. And the first thing that we're going to do is we're going to make our chart. The first one that we're going to work with is y to the 3x. So let's pick some x values. Let's do -2, -1, 0, and then 1 and 2. So with -2, we have 3 to the -2. And negative exponents, we just kick it down in the denominator. It goes in the basement. So we've got 1 over 3 squared, or 1 over 9. Now what happens with 3 to the -1? It's going to be 1 over 3. So when our x value is 2, our y value is 1/9. When our x value is -1, our y value is 1/3. Now 3 to the 0, anything to the 0 power is 1. That's pretty clutch. We like that. So when our x is 0, our y is 1. 3 to the first, because we're putting our x in to that formula, equals 3. So when our x is 1, our y is 3. Now 3 squared is 9. When our x is 2, our y is 9. Whew. That's kind of our base parent function that we're looking at here. Now with this 3 to the x plus 1, I'm going to rewrite it to make it look a little bit different, but it means the same thing. Anytime we've got addition in the exponents, we're multiplying things together. So this is equivalent to 3 to the first times 3 to the x. And I just use that because it's a little easier for me and to think like that. And we're going to do the same table with the same x values and see what we get. X, we've got -2, -1, 0, 1, and 2. And part of the reason that I do that is I've already got 3 to the -2, right? Because I've got 3 times 3 to the -2. Well, earlier I figured out that 3 to the -2 is 1/9. So this is 3 times 1/9, or 1/3. So when my x is -2, my y is 1/3. This is 3 times 3 to the -1, which is 3 times 1/3, or 1. X -1, y 1. Now 3 to the first times 3 to the 0. Anything to the 0 power is 1. So 1 times 3 is 3. And then 3 times 3 to the first is 9. X1, y9. 3 times 3 squared is 27. Now let's plot this and see what we get. We've got our x-axis and our y-axis. We're going to do the y to the 3x first. This is going to be 1, 2, 3. So we're going to guess. 1/9 is here, 1/3 is here, 1. We're going to have 3, and then somewhere up here. We just draw a line connecting all those dots. And this is a graph of y equals 3x. Now let's draw out y equal, or f of x is 3 to the x plus 1. -2, we're about 1/3. -1, we're at 1. 0, 3, and then it starts to go up really fast, so we're just going to draw it up here. We connect these dots, and the orange is f of x equals 3 to the x plus 1. This is one example of transformations of exponential functions. If you'd like to see more, let us know. Real quick, just review the chart. If we have a plus or a minus outside of the base in the exponent, it's a vertical transformation. If it's included in the exponent, it's a horizontal. Now, if we've got the negative in front of that base in the exponent, you're going to flip it around the x-axis. If we've got the negative with the exponent, we're going to flip it around the y-axis. Now, if we're multiplying our base function and exponent by something else, that's going to be a vertical stretch or a shrink. And if it's attached to the exponent, it's going to be a horizontal stretch and shrink. So practice and have some fun. Have a good day. There we go.